Taiwan University. It's my honor to be the chair of this afternoon section. First of all, I have to announce something. I have to remind you that during the fight, we will not be able to use the internet, and recording video, audio, taking pictures is also not allowed. And please do not grab it from dot to block the projector. I think all of you already tried the projector is good connection with the computer. Okay. Then first of all, I would like to introduce the jurists in this afternoon section. Other than me, we have Professor Liu Xiangling, Professor Li Hangqi, Professor Chen Jianqu, and I would like to invite all the teams to introduce themselves. Perhaps we start from the reporter.
Hello everyone, we are from Team TYPT, and my name is Wu Xiaoqi. She is Lai Chenxi, Zhang Yun, Guo Zilin, and Lai Huiru. Thank you.
Hello,
I'm Jing Rocky, and I'm the captain Liu Lingqian.施立成、蔡志宇、徐国兴、蔡凯。Thanks.
I'm the captain of Mingdao PF3. I'm Xie Wanyu, Xu Zherui, Wang Yian, Lai Mingyu, Zhong Yizhen. Thank you.
And we have the board team, observers.
Hello, we are from Girls from Cheshire Academy. I'm Liu Xingxi, Wang Ruihong, Wu Zhenyan, Zhang Youduan, Yan Shengyu.
Okay, thank you all. So let's start the first stage. The opponent, please raise your question. Problems, papers, for the opponent.
Air question.
The number. Okay. Problem number 16. Okay, accept. So this start with get ready for your presentation.
对，这样可以。这样辛苦。
Hello everyone, my name is TYPT D101 and today I'm going to present turbulence distinct chemical. And here's our problem statement. Place an object on a large air cushion and drop several other objects in such a way that the first object is catapulted away. Investigate how the axis velocity depends on relevant parameters. And in this problem, we are mainly focused on the axis velocity in every experiment and the main factor which causes axis velocity to change. And here's our experiment video. As you can see, we cut the rope that is attached to the drop object, and then the other object will catapult it away. And this is our observation. We put side views of the time when the object is catapulted away. So we found that if we put the drop object at point 2, and then we put the object that's going to be catapulted away at point 5, the motion between these things will be projectile motion. And we think that the reason why this will happen is because the airflow is more circular. So it won't just give the catapulted object a force to go up. It also have other force to give it. So that's why it will have projectile motion. And we also found that if we put the drop object at point 1 and we put the catapulted object at point 6, the motion will be vertical. And we think the reason of that is also because of airflow. And by this time, the airflow is more concentrated. So it gives more force for the object to go up. So that's why it will have a vertical motion. And the next part is the calculation of velocity. We calculate active velocity, and we found that when the object is first leave the cushion, the velocity the y-axis velocity and x-axis velocity will all accelerate. And the x-axis velocity will decrease is because we consider right side as the positive side and left side as the negative side. So that's why the x velocity will decrease, but it also means that it is getting faster. And next part is the energy transformation. So at first we place the object at a certain height. So it will have a potential energy. And after the object is dropped at the cushion, because the potential energy will transfer equal to a constant. And the next part is our experiment setup. We have a bracket and we use a rope to hold the drop object at a certain height. And we use a scissors to cut the part that the rope is attached to the drop object. And we have a force sensor under the cushion. And we also have pressure sensor to sense the pressure change inside the cushion. And we can also control the same amount of pumping. It's 0.4 liters one time. So if we can control how many times we pump the air inside, we can know the air volume inside the cushion. And the next part is we change height of drop object. We have 50 centimeters, 60 centimeters, and 70 centimeters. And also we control the gas volume at 30 liters. And the weight of the object is 100 grams. Contact area is 1.3 pi, and distance between two objects is 22 centimeters. And as we can see from the chart, when the drop height increases, the axis velocity will also increase. And if you can see from the energy transformation formula, in the left part, the height increase, so the h here, so the h here will increase. And so the h will also increase. And because the other two remain the same. And then at the next part, so because the h increased, so the v will also increase. So that's why the x velocity will increase. And the next part is we change the weight of the object, which is also the object that is catapulted away by the cushion. So we can see from the chart that when the weight of drop object increases, the x velocity will also increase. And to explain that, we can also use the energy transformation. So the m here increase, so also the v on the right side will also increase. And as you can see from the chart that we just talked about, when the weight of drop object increase, the difference between theoretical and experimental value will also increase. And we think the reason of that, is because the air we put inside. Because when we are doing the first two experiments, we all pump 75 pumping into the cushion. So if we pump 75 times into the cushion will be very hard. So it will be really hard for it to deform. So because the deformation is not big enough, the deformation change is not big enough as the weight change. So that's why the experimental value and the theoretical value the difference between these two will increase. And the next part is gas volume. We have gas volume at 18 liters, 24 liters, 30 liters, and 22.8 liters. And we can see that from this chart, pumping at 60 times costs the maximum active velocity. So pumping at 60 times is also the 24 liters of gas. And we see the reason why the active velocity will not have a positive relationship with the gas volume is because if we have too much gas volume in the cushion, it will be hard for it to deform. But if we have too less gas in the cushion, there will be no air for the energy to transform to the other object, and also it will waste too many energy at deformation. So we think that is why pumping at 60 times, which is also the gas volume at 24, will reach the maximum velocity. And next part is different contact area. We have contact area at 51, 29, 16, and 100 centimeters squared. And we all control the object at 100 grams. The drop height is 50 centimeters and gas volume is 20 liters. The distance between two objects is 22 centimeters. And from this graph, we can know that as the contact area increases, the x velocity will also increase. And we think the reason to this is because of Pascal's law. In Pascal's law, if you press this side of the tube with a force called F1, and then if we think of the area here is A1, and they will create another force to push the other part of the tube, which is if we consider the area of it is A2. So in Pascal's law, F1 divided by A1 will equal to F2 divided by A2 will equal to the pressure. So in our experiment, our F1 and our A1 is fixed. So we can know that when our contact area increases, our F2, which is also the force that the cushion gives the object, will also increase. So that is why we say that when the contact area increases, the x velocity will also increase. And the next chart is the distance between drop and catapulted object. And we have this object distance at 22 centimeters, 36 centimeters, and 40 centimeters. And our control our flying object at 100 grams, drop height at 60 centimeters, and our contact area is 1.3 pi, and our gas volume is 30 liters. And we can see from the chart that when the distance between two objects increase, the x velocity will also increase. And we think the reason why this will happen is because when the distance between two objects increase, it means it is more close to the edge of the cushion. So just like what I said in the observation, it will create a more concentrated airflow. So that is why the x velocity will increase. And to our conclusion, we use ideal gas equation to explain why when the volume of the air decreases, the pressure will increase. And we use Pascal laws to explain why when the contact area increases, the x velocity will also increase. And I use energy transformation to explain our experiment of weight of drop object, weight of catapulted object, and release height. And for our gas volume, we know that if you have too much air or too less air inside, it will not give the object a maximum exit velocity because it was either too hard to deform or it will deform too much that energy will be consumed during the deformation. Thank you.
Okay. Questions from the students?
Okay, in observation, the force that act on the object stays vertically. You say it will do the projectile motion. Is the picture is wrong or something?
No, I said that if you put the two objects at different points, they will have different kind of motion.
You say? Okay. And I want to see the chart in page 9. Observation. I want to see the chart. In one chart you didn't put the arrow bar in it.
I will put the arrow bar in the chart just because, the arrow is really small and because the arrow bar is really small and we have to make every data point is clear enough for you to see. So maybe they cover the arrow bar, but we also do put the arrow bar as every chart.
And is the energy of falling object would totally transform to the cushion vicinity balance?
No, will have energy loss.
Okay. And do you consider the contact of time because you measure it force, but you also need the contact time so that you can calculate the momentum transfer to the cushion?
You mean like how long did the thing contact to the
cushion?
No, I don't think that is the main point because at the point that the collision happened, the other object have already bounced off. So they will not create another force for the object. Those things are not related.
Okay.
Okay. So, according to variable feature, is a thing.
object is catapulted away. Investigate how the extreme velocity depends on the relevant parameter. And then focus on how the extreme velocity affect the experiment and factor that cause the velocity to change. And the report summary is their theory is energy transformation, and the experiment is change the height of the drop object. And the result is the heavier the drop object weight, the higher the extreme velocity will be. And the bigger the contact area is, the more extreme velocity it will be. And the farther the distance between two spots increase, the higher the extreme velocity will have. And for reporters, their process, their detailed explanation is good and complete experimental process. And consists they have the wrong picture and lack of the factors considered and lack of error bar.
You want to start with the discussion?
Yeah. Can you change to the observation? Yeah. On the left, if this force is vertical to this object, why will it fall like different side and not just?
No, this is just the graph. What I want to say is that it will have a vertical motion. So
Also, this graph is
yeah,
wrong.
because it's really hard to draw a graph that it will go back again. So that's just a graph that I want to tell you that it's a vertical.
Okay. The second question is, although the distance between two objects is the same, will the different position of the object influence the result?
Sorry?
These two objects, one object is there, and the other object fall down, and this is the distance is the same. And will this object change there, and will the result change?
You mean the distance is the same, but the
Position.
But the position is different. I think it will change.
So in your experiment, the other object is all in the same position.
Yeah.
How do you to ensure it's in the same position?
Because we have a rope here, right? And we will make sure that this part is the object will drop to the point that we want. So that is how I make sure that we have the same spot every time we use the ruler, and we use the ruler to tell that it's like we use the ruler to fix the location of the object that is going to drop.
Okay, and won't the cushion move?
It won't move.
So it was always in the same place.
Yeah.
And if you use a scissor to cut that line, will it move by the scissor and go in a different position?
No, because we just cut it. It will not really make the drop object move.
Okay. Next question: how to avoid the different direction that catapult away the second object? Do you think keep the catapult object vertically to the horizontal is vital to calculate the energy, because you need to calculate the height? I said if this thing and the cushions, their angle is important.
You mean the angle between the flying object and the cushion?
Yeah.
We don't do that part of the experiment, and basically we control that but the object is just on the cushion. What do you mean the angle between the object?
Because the object is not horizontal to, because it has like this. So.
Oh no. That's if you can see our video, we don't. This part is flat because we have a flat area at the top. Because our cushion is not just like two parts of.
But you know that this cushion is soft, so it has different angle. So.
Yeah, like if maybe it will have different angle, but I think the angle will not really affect the result a lot because also we have error bar, so I think we can
if a gas volume over 30 liters, you say it will too hard, right?
Yeah.
And do you measure the area that the cushion of and the force detector detect?
Yeah, we test for you mean the force sensor we use? And we have the sensor to test the force that the cushion gets. But I say that because it won't have a maximum velocity, because when the volume is too big, the deformation will not be a lot. Because it is hard for the cushion to deform. So if it is hard for the cushion to deform, it will be hard for the other side of the cushion to have the air to bounce, have the power to bounce the caterpillar object out.
Yeah, but you say, because you say it will be a cushion, but you also need an area to calculate the cushion.
Which part of the area?
Because the pressure is on the cushion, right? So you have to calculate this object on this cushion's areas to calculate the pressure it offers.
So you say you mean the force detector, or you mean the pressure detector that I still have to consider another part of
Okay. Is the bag filled with gas, or it still can be pumped with the gas into the bag?
Is the bag full of gas?
Yeah.
So you mean it's so it's not full of gas, because if it is full gas, it's just like this chart. If it is full gas, the maximum the x velocity will not be will decrease. So we don't use the maximum gas volume inside. And also because we use pumping to control our gas volume, so we just control the pumping. The gas volume is same when we do the experiment.
Okay. And I want to know if the air cushion is full of gas, is very hard. If another things go down and this catapult object, will it fly lower or higher?
I didn't really consider about the height in my experiment, but I think if we have increase the gas volume, I think the height will decrease.
Why will it decrease?
Yeah, because the actual velocity will decrease, so the maximum height will decrease. But I didn't do an experiment, so I have to just guess.
Okay. And if the cushion is soft, right? So if the second object falling down, then will the ripple this object make affect the other object? Just like we threw a stone into the water and there will ripple. Air ripple.
Yeah, but it's a cushion. It won't have if it's not that it will just have a part that goes down. The cushion will have like a bump under it, but it won't have a ripple.
You won't have a ripple, but okay. And after an experiment, the cushion be reused again.
Yeah.
Why? Won't it be become other shape or affect the experiment?
We will control the shape of the cushion every time, so we don't have to change the cushion every time we use, because I think the main factor to the cushion at the end is just whether the shape of the cushion will change. But we have already made sure that the volume is the same, so we just have to make sure that the shape is the same. So we don't have to renew the cushion every time we do the experiment.
Okay. And do you think air resistance play a role?
Yeah.
So do you calculate it in your experiment?
No, I didn't calculate. That is just the theoretical line I draw is just from energy transformation. I didn't calculate air resistance inside this, but in this chart I say that the reason why the deformation, difference between deformation and the difference between the wave will not be the same is because of energy loss. So energy loss may happen because when the object is catapulted up, it may rotate. So that is one energy loss, and the other is because of air resistance, just like you said.
So you mean the energy loss may be caused by air resistance?
Yeah.
Okay. And do you think there will be a way like you throw in the picture we show the experimental device, why the object will fly in this way?
You mean the video? Yeah. It's a projectile because it's not at the two sides.
So this object falling down and this object down, will this object falling down always like this way?
You mean
Or maybe bounce to another direction?
you mean the catapulted object or the drum object?
Oh, the catapult object.
I think if we use different shape of the cushion, it may have they may go another way, but because our cushion are flat at the top, so it will just go either projectile or vertical.
So you don't try another object or cushion?
No, that's another cushion. And because I think this question is mostly about velocity, it didn't really talk about the paths of the object. So that's just my observation.
Okay. Do you think all the energy of falling object transform into the energy of bounce up? No. If you say this no, then where will the energy go? Is it only like air resistance or like other things, other cores?
Other energy law is like because we say that the volume of the air reaches also the volume of the cushion will decrease. So they will lose some energy at the cushion's deformation. And also because like you just saw the video, the object, the catapult object may be rotating. So the rotating will also cause an energy loss. So it's not the air resistance, it also have the deformation and the rotating part.
Okay, so this part didn't calculate in your.
Yeah, because that's just energy transformation, and I explain why the difference will get bigger, because I know that we didn't face it to the real situation, but we can know the relationship between two things just from the theoretical line.
Okay, so
Hands up. Please summarize this discussion.
in the discussion time we talked about the factor that will affect the outcome of the experiment, such as the setup of the experiment, and we mainly discussed the surface on the cushion. And I asked if the ripple, like the object make, will affect the other object. He said there's no ripple. And I asked, is air resistance or other force in fact this experiment? And she said yes, but it's so little, so he didn't count it in. And I asked if the
First I want to ask the report and also what is the main factor to this experiment? What do you think the main factor?
I think
ripple get to another object first, or the ripple infect the other object, it will bounce in a different way.
The line in your graph, your radical value, the line. And what are the relations between the dots and the line?
The dots is the experimental value, and the line is the theoretical value.
And what caused the difference?
We said the difference is because of energy loss. Because we just consider this is just the theoretical is just energy transformation.
What caused the energy loss?
Energy loss is caused by air resistance and then the rotation of the catapulted object and also the deformation of the cushion.
Okay. And next question, both of you, what other factors do you think will change the exit velocity? What other factors do you think will change the exit velocity?
I'm saying the shape of the cushion.
Oh, okay.
I think the type of cushion and the material of the surface.
And why will the exit velocity change when the distance changes?
Exit velocity.
Yeah.
Because I said that when the distance changes, that means that the drop object and the flying object are more near the edge. The airflow will be more concentrated. So that's why I say that when the distance between two objects increase, the exit velocity will also increase.
Is there any evidence from the theory?
No, it's not from my theory, but that is just my explanation. That's what I think.
Thank you.
Brackets, objects, flying objects.
we think that the collision time will affect the momentum. And the third discussion is that the opponent acts from same distance or different velocity, will the result change? And the required answer that yes, they control it by dropping the object by a rope, and we agree to the requirement. And the fourth discussion is, I asked, will the angle, the opponent asks that will the angle between collision and object affect the collision itself, and it may have different angle. And the requirement answered that that won't really affect a lot, so they will have an error bar. And the next discussion, the opponent asks that is the collision wall gas, and the requirement answered that the collision wall with wall gas is too hard for the phenomenon to happen. And next discussion, the opponent asks that do you think air resistance will affect your experiment? The required answered that the energy loss is caused by air resistance. I would think that the effect is negligible. And next discussion, the opponent asks that why will object fly in the way that the demonstration video do? And the required answer that the different shape of the collision remain different. And we think they should do the experiment changing the shape. And I asked whether change of the shape of water affect the experiment. And I asked what's the manufacturer in their experiment. And the required answer that it's the weight of the object. And we think that it's the change of impulse of the momentum. And the next discussion is what caused the energy loss and the opponent. We think that they can make the correction and fix the theory data. Thank you.
Now I'm going to give a remark about the question number 16. And in the opponent and reviewer's overview of the presentation, he said that our data lack of the error bar, but we have experienced the sure question part that actually we have put the error bar on the chart, and the error of the data in the same situation will not form a large error in the same situation, and we need to let the data point more easier to see on PowerPoint. So the dot is bigger than the error bar and cover the error bars. And the reviewer say in the presentation that we didn't control the initial gas volume in the cushion, but actually we have control by control the time of pumping. And also the opponent asked me a lot of questions about experimental accuracy and the experimental phenomenon that we think maybe we need to repeat our experimental conclusion again to let you more understand what the experiment is about. So for the experiment part, I changed weight of the drop object, weight of flying object, release height, contact area, and distance between two objects. And from the chart of these 5 elements, we can see that when these increase, the axis velocity will also increase. And we also do the gas volume part. And we know, and from our chart, we know that if there's too much air inside, it's difficult to deform, so x velocity will also decrease. And if it's too less air inside, they will lose too much energy at deforming the cushion because it is really easy to deform, and also it don't have enough air to transform the energy. So the x velocity will also decrease if there are too less air inside. And thank you.
Questions from the viewers?
I have a question, just a very simple question for all of you. So, in this case, the momentum matters or not? Why? So you can report it. The momentum matters or not?
Momentum is a key factor in the system.
Which part of the
In this system, we talk about you analyze those stuff, right? So in this system, you only talk about energy. So then my question is, the momentum matters or not?
I think yes, because the momentum change
So you agree it's important.
Recorder, could you go to your page 15, your resolution? 15 slide. Could you go to this presentation mode? Too small for me. 15, conclusion part. I have a question for the opponent and the reviewers. So looking at the parameters the reporter considers, from your opinion, opponent and reviewer, is there a missing parameter they don't think about? Is there any missing parameter they should consider for their further experiment? From your own opinion, is there missing parameter the reporter should consider for their experiment?
Volume of gas.
Sorry?
Volume of gas inside the cushion. Gas volume.
Gas volume. They consider the gas volume. They use different volume of the gas. Missing parameter.
Is there anything important that they didn't cover?
So I want to ask the opponent and the reviewer their opinion. So opponent, do you have any suggestions for the reporter?
Maybe the shape of the surface.
The shape of the surface of the cushion.
Yeah.
Thank you.
The
Reviewing
mole
want
of
to add
the-
some, huh?
The mole of the air.
The
Mole. M-O-L-E.
more. That's related to the gas volume. Thank you.
Very quick question. There's no other questions. In a reporter's experience, it seems a large energy loss in the case. So I would like to ask opponent and reviewer, what's the major cause of this energy loss? Just a simple fact. Do you think what is the most important is cause this energy loss?
Turbulent flow in the cushion.
Pardon?
Turbulent flow.
Oh, okay. Okay.
Okay. I think the
still doing this problem. I would like to announce first, we will have only 10 minutes break before the stage, since this is a full stage section. Okay, let's go for the recorder. Okay, 76555. Let's go for opponent. 66554. Score for the viewer. 66665. Okay, thank you. Any comments? No? Okay, that's 10 minutes left.